Hey y'all, welcome back. Today we are going to learn our final method for solving quadratic equations. So far we've looked at three distinct methods for solving quadratic equations. The first method being graphing, where we graphed the parabola of the related function and identified the x-intercepts. The second method we looked at was solving by factoring, whether it be factoring a greatest common factor out or just using the traditional grouping method. In either case, we use the zero product property to solve each individual factor as we set them equal to zero. And the last method that we learned last class was solving by square roots. And we saw that this was useful in two different contexts. One, if you don't have a linear term, like you don't have a bx term in your equation. And also if you had like a binomial squared, you could use that technique as well. So today we're going to learn the final and what I like to call the ultimate method for solving quadratic equations, and this is called the quadratic formula. Basically, it's going to be a formula where you pick out the a, b, and c out of your equation and plug them into this formula, throw it in your calculator, and you're pretty much done. So we'll go over exactly what the formula is, how to use it, and go over the different conditions on which you need to make sure your equation is set up with before you use it. So without any further ado, let's jump right into it. Like I said, we've learned three different ways for solving quadratics. The first way was graphing, where we graphed the related function and found the x-intercepts, and we found that the x-intercepts corresponded to the solutions of the quadratic equation as long as it's in standard form. The second method we used was factoring. So whether you had a greatest common factor that you could factor out, or you just factored the trinomial into a product of binomials, we could use the zero product property to solve a quadratic equation. And then last time we saw that if we didn't have a linear term, if we had something like 4x squared minus 9 equals 0 or something like that, we could use square roots to solve quadratics. But today is the day where we learn the ultimate method for solving quadratics. Okay, it's the ultimate method. And the reason why I like to call it the ultimate method is that it will work for any quadratic equations. There are no restrictions on this. Now, the downside is it is a pretty beefy formula that you'll have to memorize. I guess this year you probably won't have to memorize it because you'll be given it, but in general, long term, you'll want to commit this to memory. And this will work for solving any quadratic equation that's set up in standard form. And again, what I mean by standard form is that the equation is set up like this, where the terms are in descending order based on degree. You have your quadratic, your linear, and your constant. And we're going to call the coefficients of each term a, b, and c. And you got to make sure that it's equal to 0. So as long as this is set up correctly in standard form, and we've been practicing this whole unit putting quadratics in standard form, then you will be good to go for using this formula, where essentially all you're going to do, like I said, is we're going to pick out these values of a, b, and c, plug them into the formula, and we'll get our solutions. All right, well, without getting too much into it, let me just go ahead and give you the quadratic formula.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
That's right, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And I'm going to keep playing that song every time we bring up the quadratic formula because I think it's a good way to help force your brain to remember it, even if you don't want to. Sometimes just hearing a catchy tune can kind of commit these parameters to memory, because otherwise it is kind of a long formula that can be easily forgotten or incorrectly written. So once again, the quadratic formula here is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, one thing I want to pull your attention to is this little plus or minus right here. So if you'll recall, that when we graph these, oftentimes the graph is going to have two solutions, right? Like I'll just do a quick little sketch here of a parabola. But when you have two solutions, that means that the related equation is crossing the x-axis twice. So what this plus or minus is doing here is allowing us to find both solutions with one formula. So after you plug in all these values, you're going to separate out the two solutions by writing it once with plus and once with minus. And I'll kind of show you how that works as we work out some of these. But just know that the whole reason you have a plus or minus is because there's actually two equations here, one with the plus and one with the minus. So you have to do both, and that way we can get both equations. It is possible that you have just one solution, like we saw if we had a parabola that kind of came down, hit the x-axis, and then bounced back up. And in that case, you'll see that you have like a 0 underneath here, and we'll talk more about that in a little bit later. So let's just jump into some of these examples. I think the best way to really become familiar with this quadratic formula is to actually just start working some problems. Okay, we'll identify what A, B, and C are, and then just plug them in. It's really that simple, and just make sure that you're using a calculator to simplify everything. I won't throw in the entire formula into a calculator typically. I'll typically kind of simplify the expression piece by piece, and you'll see me do that. So let's take a look at number 1 here. 2x squared minus 5x plus 3 equals 0. Now we could try to solve this by graphing. We could even potentially solve this by factoring. The square root method's not going to work because we have this linear term, but we're going to forego all those previous methods and just use the quadratic formula. So just as a reminder,
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So before we actually plug anything in here, let's identify what A, B, and C are. So you're going to pull those from the coefficients of each term. So we have A, B, and C right here. And I'm just going to make a little note so that I don't have to keep looking back at the equation. I'm going to say that A is 2, B is negative 5, and C is 3. So as long as your equation's in standard form like this, it should be pretty easy to identify what A, B, and C are. And then from there, it's just a matter of plugging everything in correctly. So let's go ahead and do that. So I'm just going to make a copy here of the quadratic formula. And everywhere where I see A, I'm going to replace it with a 2. Everywhere where I see B, I'll replace it with a negative 5. And everywhere I see C, sorry about the bells, I'll replace that with 3. So, like for instance, A is going to be 2. I'm just going to replace it with a 2. Here's another A down here, so I'm going to replace that with a 2. My B is negative 5. I want to be careful with this first term because the formula's set up with this already being negative. So even if when you're plugging in a negative, you just want to make sure you don't lose a negative there. And we should have like negative 5, or the opposite of 5. And so what ends up happening here, and I'll simplify it on the next step, but these negatives just sort of cancel out. When you have the opposite of 5, you just have 5. Or negative 5 is positive 5. Same sort of thing happens over here. When we square a negative number, we're going to end up with a positive. So we'll just keep that in mind and make sure we don't work this out too quickly. The last thing here is C is 3, so I'm going to replace C with 3. And now I've got no variables left, right? This thing is ready to go, so I'm going to just start plugging stuff in the calculator. I don't want to put the whole thing in there. Usually what I like to do is just simplify this little piece first. This piece is called the discriminant, and we'll talk about that towards the end of today's lesson. So I like to simplify basically 3 parts. This part, if I need to, if this is positive, there's not really anything to do, or rather if B is positive. So I want to simplify this separately. I'm going to simplify the discriminant, which is everything under the square root, and then I'm also going to simplify the denominator separately. So I'm just going to, let's go ahead and do that. So negative 5, or the opposite of 5 is just 5. So this I'm just going to replace with a 5, positive 5. And this I'm going to put in the calculator, okay? I could probably do it in my head, not like trying to brag or anything, but it's not that complicated. 4 times 3 times 2 You could probably do that too. But let's, just to be safe, anything where there's like multiple operations happening, it's probably a good idea just to make sure we're right rather than just, hope that we are. So make sure to put that negative in parentheses here when we square it, otherwise we're going to get a negative 25 here. Minus 4 times 2 times 3, and I could just type in like the times button here, but I just like to kind of try to make this look exactly like what I have. Oh wait, you can't see what I'm on my calculator, my bad. Let me bring that up. There we go. So I'm going to, what I was saying was I want to type this in exactly how it looks, okay? So like notice that, I have all these parentheses here versus just pressing the times button. That's okay, okay? It gives me peace of mind knowing that what I'm seeing on the problem looks exactly as what I'm seeing in the calculator. So I hit enter. Oh, look at that, equals 1. Okay, so all that stuff underneath the square root is just going to be 1. And then 2 times 2 is obviously 4. Probably don't need a calculator for that. So from here, you're going to do one of two things, okay? You're going to either put this whole thing in the calculator or you're not. And the way you know whether or not you're going to need a calculator to actually get your final solutions here is whether or not this number is a perfect square. So perfect squares are something, a number where an integer times itself will equal that number. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. So 1, 4, 9, 16, 25, 36, etc., etc. Those are all perfect squares that will, when you take the square root, it gives you a nice number. So either way, I'm going to separate out, and this is what I was talking about at the beginning with the whole plus minus business. I'm going to separate out this statement into two separate solution statements, okay? Because I'm expecting two different solutions here. In fact, if I jump to the calculator just briefly, we can see quickly how many solutions we have. Okay, if I just type in the function that we have, 2x squared minus 5x plus 3, and just take a quick peek at the graph, you can see that, it almost looks like there's only one solution here, actually. Let's zoom in. Be careful, the pixelation on these is horrendous. So, okay, so zooming in makes it a little clearer, and I'm gonna, oops, oh boy. I want to zoom in a little bit more just to make it a little bit more obvious, except I don't want to zoom in at the origin here. I'm going to zoom in over here where the relevant information here is. Okay, so now you can see if I zoom in enough, we are expecting two solutions that should be pretty close to one another. So, okay, so zooming back out, we can get out of that. I just wanted to take a quick peek and see how many solutions I should expect to get. So let's go ahead and write out our two solutions here. So the first one, I'm not going to jump straight to the answer. What I want to do is just kind of simplify this a bit. Say x equals 5 plus, now the square root of 1 is just 1, so 5 plus 1 divided by 4, and we'll have 5 minus 1 divided by 4. And both of those you could put in the calculator, okay? Let's bring the calculator back up and hide it over here a little bit. I don't want to cover it up too much. Okay, so yeah, we want to put both of these in the calculator. So I'm going to hit alpha, y equals, make a little fraction here, 5 plus 1 divided by 4, and 5 minus 1 divided by 4. So what I want to do here is kind of show you two different ways on how you can input this in. Because depending on how you input it in, you will get either a fraction or a decimal. Oh wait, so this one actually worked out to be a whole number, so this is not a good way to put. Let me do the first one again. So like if I do like I did before, I don't know why I deleted that. 5 plus 1 divided by 4, I'm going to get the fraction. Or if I do 5 plus 1 like this in parentheses, which this basically means the same thing, but this will give me a decimal. You can do either one. I think since we have a terminating decimal here, it might be wise to just go ahead and include the decimal here. So we get 1.5 as one of our solutions. And then I think we said the other one was 1, but let me just go ahead and put that in again. So yeah, we do get 1 as our separate solution. So we get 2 answers, and we were expecting 2 solutions that were pretty close to each other, and these look pretty dang close to each other. Just looking back at the graph here, it does sort of appear that our solutions are at 1 and 1.5. See, so we're getting a solution like here, and then another one right here. And so that matches up with what we got algebraically. Okay, so that's one example. We'll do a few more, but the basic idea here is going to be the same. We're going to identify A, B, and C, and then we're going to plug it in to the quadratic formula. So let's look at number 2. All right, number 2. Let's identify A, B, and C. Now be careful. I've noticed on the past couple of tests, maybe not tests, but the past few assignments, where students are incorrectly identifying the coefficient when a number is not visible. So like, look at this first term, x squared. If you don't see a number in front of there, then that parameter is going to be 1, okay? Because 1 times x squared is x squared. So it's not 0, it's not x squared, it's just 1. So that'll happen anytime you have no number. Like if this was, let's say this was 2x squared minus x. Well, then this would be -1 in that case. C here is 5, and then we want to go ahead and write out the quadratic formula and plug everything in.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
I know you're probably getting tired of hearing that song, but I'm going to play that literally every time we work a problem out because I'm trying to get it stuck in your brain. Okay, like hearing a great song. If it can get stuck in your head, that's kind of what I'm going for. So like tonight when you're eating dinner and you start, maybe it's a little quiet, this song will creep into your head. Just because I want you to be so familiar with it. Okay, so I know it might sound a little annoying, but you'll thank me later. So let's go ahead and plug everything in. We've got A, B, and C. Okay, my A is 1. My B is -6. And I'm putting everything in parentheses. It just makes everything kind of nice and clear. So -6, A, and then C is 5. I want to bring up my calculator here to simplify everything that I can. So let's see here. I can move this over. So I'm going to just copy this. Oh, whoa. Calm down there. Okay, that did not look right. Let's try that again. There we go. Okay, so -6 is just +6. I don't need a calculator for that. But I am going to put the discriminant, this thing underneath the square root, in the calculator. So let's go ahead and clear out everything else. -6 squared minus 4 times 1 times 5. And I put that in differently. Let me do it the way I did it last time. You can do it that way. That's not a big deal, but I kind of like it this way. 16. Okay, so that's going to be nice because 16 is a perfect square, right? The square root of 16 is 4. So this problem's going to work out real nicely. And 2 times 1 is 2. So from here, we want to separate this out into 2 separate problems, or 2 separate solutions, rather. So I'm just going to take this and kind of copy them over, except I'm going to change the square root of 16 to 4, and I'm going to change this to do the plus or minus separately. So 6 plus 4 over 2, and 6 minus 4 over 2. So I should get x equals, and just to be clear, let's make sure we're right here, 6 plus 4 is 10, divided by 2 is 5. I don't really need a calculator for this, neither should you, but I'm just, I'm being careful. 6 minus 4 is 2, divided by 2 is 1, and so we get our 2 solutions, 5 and 1. So just out of curiosity, and it's a good idea to just kind of check your answers. But if we look in the calculator to see what the graph looks like, we're kind of expecting that the solution, the x-intercepts are going to be 5 and 1. So let's see if that looks right. We're not going to dive too deep and make sure that it is, but we're just kind of looking for generally does it kind of look right. Let me zoom back out a little bit so we can actually see it. Looks like that 1 is going to work out pretty well. So yeah, we got 1 and then 2, 3, 4, 5. Yeah. So that looks pretty good. So we look like we got the right answers. Let's go on to the next one. So 3 is the first problem where it's not in standard form yet. So we need to put this in standard form. And to do that, it looks like our a term here is negative. We don't really want it to be negative, although this will work if it is negative. But we've been practicing for so long trying to get this positive. I'm just going to stick with that. So we want to subtract 2x and add 3x squared to both sides, which will give us an equation that's in standard form, that is 3x squared minus 2x minus 7. So from here we can identify our a, b, c. Our a is 3, our b is negative 2, and our c is negative 7. So let's go ahead and write down our quadratic formula and plug everything in.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
You're probably noticing here that I'm writing this every single time. And that's just because it's good practice. The more you can write this over and over again, the quicker you're going to commit it to memory. Now I know that this year you'll be able to look it up, so it's not 100% required that you remember this, but as you move forward in your future math classes, it will be very helpful to just know this off the cuff. So let's plug everything in. Our b is negative 2. Our a value is 3. So we'll plug that in. And our c value is negative 7. Okay. So we're just going to do the same thing here, nothing new. I'm just going to show the simplification on this guy. So negative 2 is going to be positive 2. Negative 2 squared is 4, and let's just throw everything in there. So we get negative 2 squared minus 4 times 3 times, oops, let's write it like this, times 3 times negative 7. We get 88. Okay, so this is not a perfect square. So this is going to be a case where we absolutely have to use the calculator. So underneath here we get 88, and then 2 times 3 is 6. Okay, so looks like I'm kind of running out of room here. So I think what I'm going to do is I'm just going to, what should I do here? I'm going to hide my calculator momentarily. And I'm just going to give myself a little bit more room by kind of drawing a line here and then just kind of picking up where I left off over here. So I do want to split this up into 2 separate equations. Now the square root of 88, that is something that we're going to have to put in the calculator. And I don't want you to round quite yet. So we're not going to, even though like previously, like at this point we would say, okay, well square root of 16 is 4. Well, square root of 88 is not something you can write as a decimal. We can approximate it, but we just can't, it's impossible to write it as a complete decimal. Because there's infinitely many digits and there's no repetition to any sequence of values there. So we've got 2 plus root 88 and 2 minus root 88. And let me try to squeeze this in there. There we go. Okay, so that's going to be good enough. All right, so I'm just going to basically type each one of these in there, and then we're going to have our solutions. So now I'm going to have to bring that calculator back. And I'm just going to drag it over here so we can see what's going on here. Okay, so we're going to type in, and here I'm going to actually do the fraction so I can make sure I type it in correctly. We are going to end up with a decimal here, but that's just part of life here. Okay, so 2 plus root 88 over 6 Okay, that's our first solution. And then our second solution would be 2 minus, oops, let's do that fraction again. So 2 minus root 88 over 6. And looks like we've got an extra 2 there, so let's delete that. And then, okay, so those are our two solutions. We got them. We're ready to write them down. Let's go ahead and write them down here. So anytime you're estimating, you really don't want to write equals anymore. Instead, we're going to use this approximately equal to. And it's not something that I'm like going to take off points for, but it is the correct way to write it. Now I'm going to round to 2 decimal places on this first one. It's 896. So since we've got that 6 as that third decimal point over here, that's going to round this guy up to like a 10, so 0, carry the 1. So it's really going to be 1.90 if we're rounding correctly. And then my other one is going to be x is approximately equal to negative 1.23. So I'm just rounding to 2 decimals here. It didn't specify how many decimals, but 2 is usually pretty good. So we're expecting, if I were to throw that into the graph, and we might as well do that. I mean, we've got it right here. If I type in 3x squared minus 2x minus 7, my graph should show x-intercepts at just before 2 at 1.9 and then negative 1.23. And we don't need to zoom or anything and really double check that, but it looks pretty good. It looks like those are probably right. All right, let's take a look at number 4, and then we'll talk a little bit more about the discriminant. So this is another one that is not in standard form. So I'm going to go ahead and put it in standard form. Now I'm going to change that 1/2, I think, just to make things easier to type in, as 0.5. We need to add x to both sides and subtract 10 to make sure this is equal to 0. This is something I haven't emphasized too much, but maybe I should need to start doing that, and that is that the equation must be in standard form. It must be equal to 0, or else this will not work. My a value here is 0.5. My b value is, okay, here's another one where we don't see a number in front of the letter, in front of the variable, so that coefficient is assumed to be 1. C is negative 10. And now we're ready to go on our journey for another ultimate method of solving quadratics, the quadratic formula. Let me get that calculator out of the way. I just realized that's there. So in fact, we don't really need that yet. I'm going to make it disappear. So make sure you get this copied down. So up here is where it's in standard form. Again, sorry about that. Got to keep my eye on my recording. And so here's a is 0.5, b is 1, c is negative 10. All right, now that you can actually see it, now let's jump into the quadratic formula.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, so we got our quadratic formula written down, ready to go. Now we're ready to plug everything in. So my b value is 1. Plug that in. My a value is 0.5, so I'm going to throw that in as well. Oh, geez, having trouble typing here. And then c is negative 10. Okay, so you guys, I mean, this is problem number 4 now of doing basically the same thing. So you guys know the drill, or should know the drill by now. We got x equals, now, let me copy all this, so I don't have to retype all that. So negative 1 is just negative 1. Okay, I think is this the first one where we didn't have a negative b value? I think it may be. So negative 1 is just negative 1. And then I'm going to type. Time to bring that calculator, our friend the calculator back. We need to do, let's see here, what do we need? 1 squared minus 4 times 0.5 times negative 10. And we get 21. Okay, so 21 is not a perfect square. So we just got to know that, hey, this is going to end up being decimals, kind of like the last one. which is not a big deal. Okay, we can do that. 2 times 0.5, half of 2 is 1, so we get 1. All right, so we've got our two solutions ready to go. Now it's time to separate them, and looks like I got enough room here that I can kind of squeeze this on here. Scroll up a little bit just to make sure I don't run out of room. But I'm going to split this up because I have a plus and a minus, and everything else is simplified. So really the last thing to do here is just to to rewrite these, but just with the plus, just with the minus. So we're just kind of separating these out just to make it a little clearer what's going on. There we go. So we got -1 plus root 21 over 1 and -1 minus root 21 over 1. So both of these are going to go straight into the calculator. We'll start with the first one. We have -1 plus root 21 divided by 1. I guess we don't really need to do that divided by 1, do we? Because dividing by 1 is not going to change anything. So, yeah, I guess we don't really need to do that separate part. Let's find the second solution here. -1 minus root 21. And then I'll just forego the divide by 1 because it's not going to change anything. So we get our two solutions here. We're looking pretty good. We've got x is approximately, again, we're estimating here. These are not exact solutions, but they're pretty close. Oh, did it not give it to me? There it is. What's going on here? Come on, Cam, you work with me here. Okay, so here we go. So if we're rounding to 2 decimal places, we'll do 3.58. And then we'll do x is approximately equal to -5.58. So, if we're looking at the calculator, if we're going to take a look at the graph, and I absolutely recommend that you do pretty much every time, just so you can see, hey, did I get the right answer or not, is go ahead and put it in your calculator, which, what do we have here? So 1/2, again, 0.5 is just a little easier to type, so I'm just going to go with the 0.5. Okay, or I'm just going to go all over the place. 0.5 x squared plus x minus 10. I'm going to look at the graph, and I'm expecting, let's see, -5.5, 1, 2, 3, 5.5, yeah, I could see that. It looks like it might be a little closer to -6, but I'm feeling okay about that. And then about 3.5, yeah, it looks pretty good too. So a little concerning with this one over here, but I'm gonna run with it. I'm gonna say, yeah, we're right. Okay, so that was 4 examples using the quadratic formula. Okay, now in previous lessons I had asked for you to figure out how many solutions there are, and we saw that there could be either 0, 1, or 0 solutions. For example, if I just have x squared as my function, if the parabola comes down and just touches it once, there's one x-intercept. In this case, there would be 1 solution. And if we're looking at the quadratic formula up here, the only way for that to happen is if what's underneath the square root or the discriminant is 0. Because the plus or minus 0 is just going to be the same thing. So that's why you would only get 1 solution. So if I add 0 or subtract 0, that's not going to make a difference. Most of the parabolas are going to have 2 solutions. For instance, if I have like x squared minus 4, you're going to see that it's going to come down and hit the x-axis twice. Now this is going to be the most common thing. All the problems we did so far had 2 solutions. This is just a quick example of it crossing the x-axis twice. But it is also possible to have no solutions. For example, if I had x squared plus 4, not 3, 4, but plus 4, this is a parabola that will not touch the x-axis at all. It'll kind of bounce back up too soon. And in this case, there's no real solution. So you might be wondering, like, how will I know if there's no real solution if I'm using the quadratic formula? Well, you'll know if what's underneath the square root is negative, because you cannot get a real number from a negative square root. In other words, like the square root of, say, -4, and I'll just show you that in here, is going to be a non-real number. There's no real answer there. Okay, and that's because if I do like 2 squared, that's 4. Negative 2 squared is also 4. So there's not a real number that when you square it, you get a negative. So that brings us to the discriminant, which I've kind of alluded to a little bit as we've gone through these problems. But let me be a little clearer about what I mean here. So the discriminant is that number that's underneath the square root, okay? It's not necessarily the square root itself, but it's this little expression right here underneath the square root. So it's the b squared minus 4ac. And we can determine how many solutions the quadratic should have if we just calculate this. We don't need to calculate everything else, but if we know this piece, we'll know at minimum that how many solutions there are. So if this number is positive, and that's what it means to be less than 0, okay, so I'll just make a little note here, this is positive, then you will have 2 solutions. If the discriminant is 0, then there'll be 1 solution. If the discriminant is negative or less than 0, then you will have no solutions. So if that number underneath the square root, will, if you calculate that, you'll know right away how many solutions there are. So for these 3 quick problems, and actually the rest of these problems down here, we're not interested in actually finding what the solutions are. We're just trying to figure out how many there are. So what we need to do is we need to identify a, b, and c, and then plug it into this b squared minus 4ac. That's really the only part we care about for this question. So maybe I will, well, let me type that, the discriminant is b squared minus 4ac. It's that stuff underneath the radical. So we're just going to compute this and decide, hey, is it positive, negative, or 0? So let's make sure that our equations are in standard form. We'll do that first, and then we'll identify a, b, and c, and then we'll answer our question. So in this case, a is, what is a? 1, and b is 8, and c is negative 3. So our discriminant, which is b squared minus 4ac, would be 8 squared minus 4 times 1 times negative 3. And we want to put that in the calculator. We don't need to compute that by hand. 8 squared minus 4 times 1 times negative 3. And I get 76. So all I care about to answer this question is, is it positive, negative, or 0? Right? And so 76 is bigger than 0, right? It is a positive number. So I'll say this equals 76. And since 76 is greater than 0, since 76 is greater than 0, or it's positive, there are 2 solutions. All right. Number 6, we're going to do basically the same thing. We're going to identify a, b, and c. Oh, this is not in standard form, so we need to actually back it up a little bit. Let's put this in standard form. I'll put that right up here. So if we subtract the 6x to make it equal 0, we would get 9x squared minus 6x plus 1. So that's what it would be in standard form. So that makes a difference when we're trying to figure out what a, b, and c are. So here, you don't want to get tripped up here. A is 9, b is negative 6, and c is 1. So when we go to compute the discriminant, it's b squared, and be careful with the negatives there when you square it. Sorry about that. Minus 4ac. And we're going to figure out what that equals by putting it in the calculator. Make sure you put the parentheses in. So negative 6 squared minus 4 times 9 times 1. I guess I don't really need to do the times 1, but I'm just going to put it in to be safe. Oh, it's 0. Okay. So since it's 0, we know then how many solutions are going to be, and we know there's going to be one solution. Okay, so we can say something like, since 0 equals 0, it's kind of a silly thing to say, but it's true, there is one solution. All right. Finally, number 7 is not in standard form, so we're going to put it in standard form, just like the other ones. Just to make it easier to type, I'm going to do 0.5. So 0.5 x squared minus 7x plus 1 is 0. We're just moving the 7x and the 1 over like we've done a million times with these quadratics. We want this to be equal to 0 so that everything works out nicely. Here the a value is 0.5, the b value is -7, and the c value is 1. So let's clean this up a little bit. It's getting a little cluttered in here, so I'm going to just draw some lines here to kind of help. All right, so get real fancy and do something like this. Okay, kind of pointless, but it's good. So let's go ahead and compute the discriminant here. So it's b squared minus 4 times a times c. I'm going off the page here, so I'm gonna have to move this over. I'll just have it go down here. Okay, so and that would equal, let's find out. Let's see, -7 squared. Are we not gonna get a -1? That's kind of disappointing. I was kind of hoping we would. Oh wait, is it? No. I think this one's gonna be positive. And you can't see anything I'm doing because my dang calculator's in the way again. Oh my goodness. Get out of there, calculator. Okay, I apologize for that. Oh, geez. Okay, we'll just take a moment, kind of take a look at what I've written down here. Let me move this over so you can actually see everything. I apologize for that. But basically here, we're just computing what the discriminant is. It's very similar to how we did the other one. We get 47. Okay, so since that's positive, we get 2 solutions again. So fortunately, we did not see one with no solutions, but I'm sure there'll be one soon. So since 47 is greater than 0, there are 2 solutions. Okay, so these last couple questions down here are very similar. They're just asking how many x-intercepts there are, and you know, it's just a slightly different question, but you're going to essentially do the same thing, right? The number of x-intercepts is going to be equivalent to how many solutions you got, so or how many real solutions you have. So so we're going to do exactly the same thing. We're going to calculate a, b, and c. We're going to figure out what our discriminant is, and instead of saying, oh, how many solutions there are, we're just going to say how many x-intercepts there are. But the process will be the same here. So here our a value is -1, b is 1, and c is -6. Our discriminant here is going to be b squared, so that's 1 squared, minus 4 times a. Okay, come on, work with me here. Times c, and we'll type all that in. Let's bring up the calculator. Get out of the way. Calculator sometimes just like eating up all my real estate over here. Okay, so let's go ahead and type that in. Don't want to hate on the calculator too much here. It is kind of saving me a lot of work, so I don't have to calculate any of this by hand. So maybe I should apologize for the calculator. Sorry, guy. All right, we get -23 here. Okay, good. I was kind of hoping we'd eventually get one that was negative. So when you get a negative discriminant, as we said before, that means there's no solution, which means that there's going to be no x-intercepts, like we see up here. So that's just going to be our answer. There are no x-intercepts. And now I just want to put a little clarifying statement so we can see why that is. So since negative 23 is negative, there are no x-intercepts. Okay, if we're trying to solve the related equation, we would say there's no solution. All right, let's identify A, B, and C on the next one. And I think I'll do what I did before just to help clean this up a little bit and just give me a little bit more space here. It's going to be a tight for number 9, but we'll make it work. Okay, here A is 1, B is negative 1, and you might be wondering, oh, where is C? So the difference between having a variable and not seeing the coefficient and just not having that term at all is if that term's not even there, then the number is 0. So a little slight difference here. So we got 1, negative 1, and 0. Let's compute the, I'm going to actually make this a little smaller so it can fit. So if you need to zoom in on your thing, I don't know if you're going to be able to read this. Maybe I'll make it a little bigger than that. Is we've got b squared, so negative 1 squared, minus 4 times a times c. So multiplying that by 0 kind of kills everything after the negative sign, but that's all right. We'll just type it in anyway. So we've got, can you all still see this? Yeah, okay, we're good. Got to remember to move that calculator after we're done with this one. We've got negative 1 squared minus 4. If you notice here, we don't even need to do the times 1 time. I mean, we don't need all this stuff after the minus sign because multiplying by 0 is just going to zero this whole thing out. This whole thing's just going to be minus 0. So, but I'm just going to leave it there anyway. So we get 1. So we get equals 1. Oh, we already have an equals. Okay, so that's positive. And when your discriminant is positive, that means that you will have 2 x-intercepts. So since 1 is positive, there are 2 x-intercepts. All right, number 10. I'm going to remember this time. Move that calculator out of the way. Okay, so number 10, here we go. We're ready to do this. Our A is 1, our B is 12, our C is 36. So let's go ahead and compute this. Negative B, I'm sorry, not negative B, B squared, thinking about the original quadratic formula too much, minus 4 times A times C. Now 12 squared, that's going to be 144, 4 times 90, 36. Is this going to, I have a feeling this might work out to 0. Let's see. 4 times 1 times 36. And yeah, we do get 0 after all. Okay, so this whole thing equals 0. And when you get 0 for a discriminant, that means you're going to end up with 1 solution, or 1 x-intercept. So since we got 0 for our discriminant, there is 1 x-intercept. So again, just to kind of sum that up, if your discriminant is positive, you get 2 x-intercepts. If your discriminant is negative, you get no x-intercepts. And if your discriminant is 0, you will have 1 x-intercept. All right, so that's pretty much it for the quadratic formula. The rest of this is really just, you want to get comfortable with all of the different methods that we've learned so far. Graphing, factoring, using square roots, and the quadratic formula. They all have advantages and disadvantages, which are listed here, and you can find those in your notes. But the quadratic formula is the ultimate method. So if you don't want to bother with trying to figure out the most efficient way of solving something, you can always just use the quadratic formula as long as you do it correctly. But these other methods like factoring, graphing, using square roots are a little bit more faster and efficient under certain conditions. For example, if you don't have that linear term, square roots is going to be way faster than using quadratic formula. If your trinomial is factorable, then usually factoring is going to be an easier way of getting your answer. So let's go through a couple of these, and we're not actually going to solve them out. We're just going to decide which method might be the best. And when I say the best, I mean like the most efficient way of doing it. So, for instance, on number 11, notice there's no bx term, okay? Okay, in this case, square roots is going to be the way to go, okay? So we're going to solve using square roots. And, you know, just kind of generically how you would do that, or sorry, generally how you would do that is you would add 72, divide by 2, and then take the square root of both sides. So just boom, 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 3 steps, and you're done. Number 3, we want to think about, okay, is this even factorable? It looks like maybe it is, maybe it's not, I don't know. Let's see, 2 numbers that multiply to give you 6 but add up to -3. There's just not a combination that does that. So the only way you could do this would be using the quadratic formula. You could estimate by graphing, but since it's not factorable, then graphing is not really going to work too well. And really, graphing is not a great method at all. Like you know, unless you have a graph or you're being asked to solve it by graphing for now, it's not really going to be one that we're going to go out of our way to use. So I'm just going to say something like, since this trinomial is not factorable, we should use the quadratic formula, which is what we did on all the examples today. Did I spell that right? Quadratic formula, yeah. And just as a reminder, the quadratic formula is this.
X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.
Oh, you guys are loving that, aren't you? I know what you're thinking. You're thinking, Mr. Schuler, that's enough. Enough of that song. All right, so the last one, we got k squared. Okay, so can we come up with 2 numbers that multiply to give me 24, add up to -10? Absolutely, that would be -6 and -4. So we are going to use factoring, okay? Since, well, sort of, well, I'm just going to go ahead and say, since this trinomial is factorable, we should use, or we should solve it using factoring. And that's just going to be generally true. Okay, you want to, that should be kind of your go-to. You know, unless you're just really uncomfortable with it, factoring is usually the way to go on a lot of these quadratics. But, you know, oftentimes there's going to be a judgment call on your part. You know, is it easier to just go ahead and use the quadratic formula here? Maybe. You know, if you're not really comfortable factoring, then the quadratic formula might be an easier way to solve it. But if you understand how to factor, then factoring is going to be a lot faster. So that's pretty much it for today. We've gone over a bunch of different methods for solving quadratics, and that's it. We're not going to go over any more. I think 4 methods is probably enough for you guys. So go ahead and start practicing using this quadratic formula, and then next time we'll start reviewing and getting ready for our test, which is coming up. All right, so that's it for today. I hope you all have a nice day, and I'll see you next time.
X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.